Hello everybody and welcome back once again. We're looking now at question 20. This is the last question in part B of our 2019 Cayley contest. In the diagram, each of the circles with centers X, Y, and Z is tangent to the two other circles. Also, the circle with center X touches three sides of the rectangle PQRS, and the circle with center Z touches two sides of the rectangle. So everything as shown. Okay. If XYZ is 30, YZ is 20, XY is 30, YZ is 20, and XZ is 40, the area of rectangle PQRS is closest to. Alright. So when I see this, and anytime I see circles that are tangent to things, I immediately connect the radii up. And the reason I do this, and I would still connect the radii when they're tangent to the other circles as well, is because if you're tangent to another circle, it forms a straight line, which we don't really need to know because they're telling us that. But over here, being tangent to the sides there tells me I've got a bunch of right angles. Okay? And that's going to be pretty helpful because we want the area of rectangle PQRS, or at least to get close to it. Which means that I'll need to figure out this side length and this side length. So how are we going to do that? Well, the first thing I see, and I'll draw my own picture in a moment in the notepad. The first thing I see is, if I can just figure out the radius of the big circle, well, 2 times that is the width of my rectangle, which is kind of nice. So as I say, let's get our own picture. And I don't know what the radii are for the various circles. But I can give them names. I don't know, that's a good enough picture. There we go. So if I gave names to the radii, maybe the big radius is R1. Then the width of my rectangle is 2R1. Okay? Maybe call the medium-sized circle, give that a radius of R2. So I can see here that 40 is R1 plus R2. This length here. Let's get an R2 here, and we'll make the small radius R3. So I can see that 30 is R1 plus R3, and 20, the smallest one, is R2 plus R3. And this is actually enough information. This is 3 equations, 3 unknowns. We can figure out the individual radii. If we add everything up on the left-hand side, we'll get 90. And if we add everything up on the right-hand side, I say I got 2 R1s, I've got 2 R2s, and I've got 2 R3s. So if I divide by 2, I get 45 is R1 plus R2 plus R3. Now, suppose I want to figure out what R3 is. Take the equation up here that doesn't have R3. Here we added all these up, and we're actually going to subtract that equation away. And we'll be left with 5 on this side, and the R1s will cancel out, and the R2s will cancel out. And so now I know the smallest radius is 5. So I can actually get rid of these R3s. So it's 5. But I know that one of these lengths is 30, so I can figure out R1 must be 25, and now I can fill that in. And as a matter of fact, we now also know that the width of the rectangle is 50. Great. Also knowing that R3 is 5, and knowing that this length over here is 20, that tells me R2 must be 15, so we can fill that in. Okay, now I want the area of my rectangle, area of PQRS. I know the width is 50. How in the world am I going to figure out the length? Well, the length runs perpendicular to the width, right? So we can already see that if we just come out from this side and go straight down, we've come a distance of 25. Similarly, if we come out from this side and go straight down, we can see we've gone a distance along the length of 15. But what's the length in between this line over here and this line over here? How are we going to work that out? It's not 40. I mean, we are told that this length here, this is 40, but you'll notice it doesn't go straight across. It goes over and down a little bit. We just want to know how far across it goes. So what we're going to do, I'll grab some blue here, is we're going to draw up a nice little perpendicular down here. And now this distance here is what's missing. So the length is 25 plus 15 plus this blue distance. How can I possibly figure out what this blue distance is? Well, I know I've got 15 here. This total length is 25. Look at that, we've got a nice little rectangle, so we've also got 15 over here, and that leaves 10 up here. So what have we got? We've got a nice little right-angled triangle. There's the distance we want, that blue distance, 10 here, and the hypotenuse is the length between those two centers, x and y. It's 40. So we just do a little Pythagorean theorem. 40 squared minus 100 squared, and we square root it to get this side. Oh, we get 1600 minus 100, so we'll get square root of 1500. So going back over here, what's this missing blue distance? Square root of 1500, which I guess is 10 times the square root of 15. So the length is 25 plus 15 plus 10 root 15. 40 plus 10 root 15 is the length, and I already knew the width, so now we can just get the area. 50 times 40 plus 10 root 15. And I think they said closest to, not exact, right? Because I did see a bunch of integer answers. Closest to. So I grab my calculator. 50 times 40 plus 10 times square root of 15. And I'm getting 3,936.49, and that's closest to E here. 3936.4916. That's closest to 3950, and that's an answer of E. And there we go. So that's question 20. We are done the part B questions. Up next, we're going to be starting part C, where each question is now worth 8 marks. They're a little bit harder, these next 5 questions that'll close the paper off. If you haven't given them a try and you want to keep watching, I would encourage you to try those questions out before joining me for 21 in the next video.